further applications of the ideal gas equation. So we'll look at how density is related to molar mass. So we're going to use this equation here. Molar mass is density times R times T over P. And I'm going to derive it for you. Now, if you don't like derivations, don't worry about it. Close your eyes, skip forward to this section. If you're curious where this equation comes from, then watch this part. I'm not going to test you on it, I just want you to know where the equation comes from. So if we start off with the ideal gas equation, PV equals nRT, and we just rearrange it. So we'll divide both sides by V, divide both sides by RT, you get N over V equals P over RT. So just rearranging the ideal gas equation, that's the first step. Now density, what is density? Density is mass over volume. So somehow I need to get rid of these moles and turn them into mass. So I need some mass in here. So how do I go from grams to moles or moles to grams? Molar mass. So mass, if this is grams equals moles times molar mass. Molar mass is just grams per mole, so my moles cancel, and I'll end up with grams. So if I want to rearrange this equation and solve for moles, because I have moles in my ideal gas law, and I want to get rid of them. Moles, I have moles is mass over molar mass. So wherever I have N here, I'm just going to substitute that in over here. So I rewrote that equation over here. So instead of N over V, now I have mass over molar mass. That's what my N is. I still have V on the bottom. That equals P over RT. Now density, we know density is mass over volume. So mass over volume, I have that right here. Right? This is mass over volume. That's the same thing as density. So I'm going to put density over there. So now I have density over molar mass is equal to P over RT. And if I just rearrange this equation, so I'll cross multiply and then solve for molar mass, I get molar mass is dRT over P. So one only needs to know the molar mass, the pressure, the temperature in order to calculate the density of the gas. So if we know the molar mass, we can get to the density. And that's what we're going to do in this next problem. So here they say, what is the density of carbon tetrachloride vapor at 714 torr and 125 degrees Celsius? So we're looking for density. So whenever you see density of a gas, it's just the density. Okay, molar mass is dRT over P. So we're going to use this equation here. Molar mass is just dRT over P. So I'm trying to solve for density, which means I know R. I always know R. R is a constant. I'm going to give you R. R is 0.0821 liters times atmospheres per mole Kelvin. Our temperature here, we need to convert that to Kelvin because we have Kelvin over here in our R. So Kelvin to Celsius, 125 plus 273 right there. Now we have our Kelvin temperature. Pressure, the same thing. We want to get that in rate units into atmospheres. So we have torr. There we go, 0.939 atmospheres. Now, to find molar mass, you had to take the name carbon tetrachloride and write the formula, CCl4, and then calculate molar mass. So I'm assuming now we're all pretty good at calculating molar mass. You can try to double check that. Remember how you do that. Carbon is 12.01, chlorine is 35.45, and you got 4 of them, so multiply that by 4, and you should get about that for your molar mass. And now we're going to plug that into our equation here. We have molar mass, we have R, we have T and P. We're just going to solve for D. So we just rearrange this equation and solve for D. And the density should be 4.42 grams per liter. We can see another application using density of gases in order to find the molar mass. Here's another problem. This one has a lot of experimental data. I'll give you a minute to read it over. We have a large evacuated flask. So they give you, the mass of an empty flask. They give you the mass of the flask and then you fill it up with gas. So if you take the difference between those, you should end up with the mass of the gas. And what else do they do here? You want to find the molar mass of a gas. Okay. So we know that molar mass is dRT over P. So if I can find D, R, T, and P, then I can figure out what the molar mass of my gas is. I always have R, and they give me T and P here, so really I have to solve for D first. So I want to solve for the density of the gas. So what is the density of gas? Density is mass over volume. So I already have the mass of the gas, So I need to find the volume of the gas. They tell me I put this in a flask. They don't tell me the volume of the flask. So you do this other part in order to figure out the volume of the flask. You can fill up the flask with water, weigh it, use the density and the mass in order to find the volume. And so the volume of water will equal the volume of the flask, which is also going to equal the volume of the gas. And so this is the mass of the flask plus water, and I just subtract the mass of the empty flask. And so this is the mass of my water here, 933.3. And now if I know mass and I know the density of water, so they tell me right here the density of water is this. So if I know the density is mass over volume. If I know density and I know mass, then I can solve the volume. So I have all this information for water. So I'm just going to rearrange this equation. Volume is mass over density. So I have the mass of water, I have the density of water, so I can get the volume of water. Then I'm going to convert it from milliliters to liters. So I divide by 1,000, there's 1,000 milliliters in 1 liter, and then I get 936 liters. And that's the volume of water. And that's also the volume of the flask, because the flask is full of water. Now, when I originally put the gas in the flask, the gas is going to expand to take the volume of the container, so the volume is also the volume of the gas. It's one volume, water, flask, gas, all the same volume. Okay, so now how do I find the density? So we already know the mass of the gas, so we want to find the density of the gas. I already know the mass of the gas, I know the volume of the gas, so I just do mass over volume to give me the density, and then I'm good. So the density is 3.09 grams per liter. And now the real problem is to find the molar mass. So now I have density, I have R, I have T, and I can just divide by P. So I plug all that in. Density times R times T divided by P, and that gives you that. So work through that problem again, and see if you get the same answer. So work through the numbers. You can always pause the video.